It's 12:01. Let's get started. Adam, let me just do a sound check. Make sure you can hear me. Okay, thumbs up. Okay, good. All right. Welcome, everyone. My name is John Hagan. I'm chair of the Maine Climate Table. Welcome to part 2 of putting a price tag on natural climate solutions, the forestry story with Dr. Adam Daigneault at University of Maine. Adam gave part 1 of the pricing presentation on agriculture back on, I think it was May 12th. And that webinar is posted on the Maine Climate Table website. So anybody who would like to see part 1 that hadn't seen it, please go to the Maine Climate Table web, which brings me to the point that we will be recording this presentation and posting it on our website as well. If you don't know the Maine Climate Table, we're a network of organizations, businesses, and individuals interested in basically 2 things: being well informed about climate issues, which is what this webinar series is all about, and secondly, engaging people on climate issues across political and cultural boundaries. It's unfortunate that climate change has become a political issue because it's going to take Democrats and Republicans to solve it in the end. So at the Climate Table, we work really hard on bridging these barriers and seeking different points of view, because our view is that it's going to take a lot of different ideas to solve an issue as complex as climate change. So visit our website to learn more about the Maine Climate Table. Before I turn it over to Adam and sort of frame up the discussion today, just a few Zoom tips. We've all become experts at Zoom in the last few months. I suggest you keep your mic on mute so background noise doesn't distract the presentation. I can mute you if that. Okay. Adam, can you hear me okay?
Yeah.
Okay.
I accidentally muted you. So.
Oh, well, thank you very much.
So it's going well.
Time's up, John. Very good. Okay. And I was about to say, in Georgetown, Maine, where I am, sometimes I lose my internet. So Adam, you can keep running this thing if I wink out, and it automatically brings me back in. I'd ask that you probably hold your questions to the end to make sure Adam can get through the presentation. If you want to ask a question, you can use the chat function at the bottom of your screen. It might be under more, but there should be a chat box, and I'll keep track of your questions during the webinar. It's an easy way for you to write them down so that they're recorded. At the end, you can also use the raise hand function in the bottom right panel. If you click on participants at the bottom, a panel comes up to the right. At the bottom of that panel is a raise hand feature, and that puts you in the queue to ask a question. Okay, transitions is what are we up to today? As most of you know, Maine has set a carbon neutrality goal for 2045, and forests and farmland are certainly going to play a role in meeting that neutrality goal. But what role is that going to be? There are all kinds of ag and forestry practices that can pull carbon out of the atmosphere or prevent carbon from going into the atmosphere. Some of those practices are more expensive per ton of carbon than others. And that's what Adam does. He figures out the cost of these different practices. Why pay $100 for a ton of carbon when you can pay only 10? You'd like to know the price of these different practices before you embark on a bunch of policy incentives. And so that's why Adam's work is so important right now, especially with the Maine Climate Council developing a plan this year to meet the state's carbon neutrality goal. So it's fantastic work. Adam would be the first to say it's still in the early stages, but he's helping us understand the most cost-effective ways to meet this carbon neutrality goal. So just to introduce Adam, he is, I gotta take a deep breath to get this out, the E.L. Giddings Assistant Professor of Forest Conservation and Recreation Policy in the School of Forest Resources at the University of Maine. At least I didn't have to say what EL stands for. Adam got his PhD in Environmental and Natural Resource Economics from Ohio State in 2006. Before coming to Maine, he was a senior economist in New Zealand working on climate change, biofuels, and land use issues. But Adam's okay because he's a native Mainer, grew up in the mid-coast Maine region and returned to Maine after 18 years of living in all kinds of other places. So Adam, welcome home. It's good to have you back. And just thank you for sharing your work with us today. It's a real treat to be able to have you here today. And actually the Zoom instrument works great for us having a chance to learn from you today. So I'm going to turn it over. The podium or the web screen or whatever you call it is yours. I'm going to go on mute.
Okay. Thank you, John. So let's all right, let's confirm that hopefully some people are seeing some slides. So let's practice with our thumbs up. All right. So yeah, thank you. So yeah, my name is Adam Dagno. A lot of you guys probably know me or I know you, but basically been spending a good amount of my career looking at issues related to sort of economics and policy of climate change and other sort of environmental resource types of issues. What I'm going to talk about today is sort of the second stage of a project that we've been working on here at the University of Maine, really looking at not just about sort of the mitigation potential that can come from a number of different land-based practices, but also the potential cost of achieving that. So, and the real approach I get at this is that you know, there's always some really good biophysical work that's been done, you know, soil samples, tree measurements, that type of stuff. On if you do a certain practice, might be how much your tree, you know, basically your tree or your stand might grow relative to another practice, and or you know, do some change some of your behavior on your agricultural field cropland. You know, you might then enhance your carbon sequestration by a certain percent. But there's less so done on sort of the economic side on, you know, beyond like, well, we know there's this much maybe capital cost that you might have to do if you have to get a different machine. Maybe at some time your yields might go down or go up depending on your practice. But ultimately, it's really how do you bring all that stuff together and really put a price tag on what it might actually cost to implement this mitigation, these mitigation practices relative to the business as usual or status quo, or relative to other practices. Again, you know, thinking about what land can do in Maine is just only one component of a much broader suite of options that are being considered, like, you know, offshore wind, changing the transportation system, solar panels, reducing consumption overall, you know, a suite of different options. So what we want to do here, the purpose of this project is really thinking about where can what we call natural climate solutions, where it's essentially just mostly, for the most part, land-based or nature-based, ecosystem-based opportunities that could be implemented in Maine. You know, what's the mitigation potential that can come out of that, and how much is it going to cost? So you can really look at that, doing a more apples-to-apples comparison. So what exactly are natural climate solutions? It's sort of a new buzzword that's emerged sort of around 2016, 2017 with a paper that was published in Proceedings of the National Academy of Sciences. But really, it's something that we've been thinking about and doing for generations, in the sense that it's really any action that can focus on conserving, restoring, or improving the use and management of forests, wetlands, grasslands, and agricultural lands, while also simultaneously increasing carbon storage or avoiding greenhouse gas emissions. So some ideas that you can think of about this on the forest side, or you can do things like protect forests, right? Put it under conservation easement, or somehow come up with a way that it can't be converted. On the management side, you can come up with ways to manage your timberlands better, so essentially gets faster growth and or you know, more mature trees in some sense. Or you can restore forests in the sense that, you know, take degraded forests or take land that once was forested, maybe has been out of rotation for quite some time, and basically bring that back into a forested land. Or some examples that you can think about just in the forest side of things. Globally, that same paper out of 2017 basically looked at a number, close to a couple dozen of natural climate solutions and looked at sort of in aggregate, what can we expect their contribution to be. And this slide is basically saying that, roughly it's somewhere along the lines of about 20% of what the Paris target sort of goal to get towards this 2-degree pathway can be met through natural climate solutions. All right, and as you get, as you get bigger and that wedge gets larger, you have to focus more on fossil fuel mitigation. But the nice thing that also comes into play with these natural climate solutions is that a lot of it can be a more near-term aspect. You don't have to do a lot of investment in certain things, right? Particularly here in Maine, we already have, most of our land is in forest, so maybe there's ways that you can change sort of the silviculture and management practices to take existing forests and sort of enhance that to help sort of ramp up what that contribution could be. In the US, basically another paper out of 2018 estimated that nature has the potential to remove approximately 21% of the nation's carbon pollution, which is really equivalent to removing all cars and trucks on the road and then some. And they've broken it out into sort of major categories: lands, coastal habitats. And so as you can see here, forest is basically, it's found to be sort of in the US, it can contribute to roughly 56% of the total mitigation that natural climate solutions could provide over the next 20 years or so. So it's really the bulk of the mitigation is primarily coming from forests. As you can probably guess, you guys saw, some of you guys might have webinar, and we talked about sort of the contribution of agriculture. Well, ag is quite small in Maine in terms of actual land cover, less than 1 million acres, whereas forests have 17.5 million acres, roughly 85 to 90% of Maine's land cover, depending on how you sort of measure it is in trees. So there is, at least on the ground, there is some potential there. The question is how much really is there, or is Maine already, reached some sort of saturation point? And that's what we're really trying to explore today. The other thing to point out is that, it's not carbon sequestration, it's also about avoiding emissions. So agriculture, forest, and other land use greenhouse gases emissions really vary depending on where and what you measure. So on the left-hand side, global ag and forest actually contributes to about 24% of all of the world's greenhouse gas emissions. So this is through either sort of livestock emitting methane, nitrous oxide, fertilizer application, but also on the forestry side of thing, it can be basically deforestation, which is essentially taking that carbon off the land, either converting into products, or in a lot of places, what they do is burn type of agriculture to do expansion to cropland that can lead to a lot of emissions as well. In the US, forests basically offset roughly on the emission side of things, and then work that's been done at University of Maine, as well as through the US Forest Service that have indicated it's roughly been that 70%. And that's going to be apparent here. So this is Maine's greenhouse gas emissions and forest removals since 2017. To understand this, look at the blue line is essentially what emissions have been. Or in this way, say decreasing, is the amount of carbon that's been removed from forests. So roughly, basically about 20% back in 1990 was removed by forests. All right, and so that's where this negative number is. All right, over time, we've now gotten to close to about 12 million metric tons of carbon dioxide have been removed every year from forests. So that's why it's negative. So the gap here indicates that actually we're getting more sequestration over time, particularly over the last sort of decade or two. All right, which roughly means then by this dotted line, if you basically do the blue line, sum that up with the green line, you get sort of the percent of being removed by forests. And right now we've gotten roughly that since around 2011, 2012, around 70% of Maine's total greenhouse gas emissions have actually been removed by forests, because we're consistently growing at something like about 12 million metric tons of carbon dioxide per year, in terms of that's how much more the forest is growing. Gross emissions less any additional sequestration that can happen through forest practices, ag practices, or even using our freshwater marine carbon through, or what we refer to as blue carbon, can all help us meet that goal. So the question is sort of, Maine does have a very ambitious goal on terms of reducing fossil fuel-based emissions, right? But they also then want to assess how do we meet the next component of that goal on the forestry, basically on the sequestration. One is the idea of avoided deforestation or conversion. Particularly in Maine, a lot of the issue is not necessarily about conversion to agriculture, which is when you think about deforestation, a lot of the world, that's what comes up. It's actually that conversion to either low density or medium density developed land. Another one is afforestation or reforestation. So it's growing trees on land that has not been forested at least for a good amount of time, a number of decades. You could do conservation or permanent set-asides. So what happens if you don't do any harvesting on a certain amount of land but still retain it as forest? Another one is to basically improve plantation management. So do more planting on existing forests after you basically fell trees, and or transition more natural generating systems to more plantation-based systems. And then another one is the idea of extending rotation. So you might, on average, a Maine's forest sort of gets harvested somewhere along the lines of about 50 years, when its sort of average age is 50 years. So the idea is if you put a sort of minimum on when you can harvest that stand and extend the rotation to upwards of 70, 85, or 100 years before you sort of go in and do any sort of felling for timber harvest, what can that do in terms of carbon, as well as the sort of economics and harvest components of that as well. And I'm going to touch upon that. That's sort of the trade-offs here, is really looking at carbon versus sort of other outputs that forests produce. So how do we go about this? The first thing that you can really want to think about or focus on is, how do we find a baseline or business as usual pathway? So in all these types of estimates, we really need to measure something relative to a status quo, or something that would happen in absence of any sort of policy focused on this specific set of mitigation practices. So often it's the continuous or current policy and practices, right? So in this case, it'd be sort of Maine Forest Practices Act is still going to be there. There might still be a continuing trend of land moving into conservation, and have conservation easements to some degree. Second is defining the geographical boundary and the temporal scale. So what are we trying to measure here, and for how long? And so that's a big component, because when you're thinking about issues, Maine is not in a bubble. The forest industry is not in a bubble, right? So there's a lot of trade flows. There's a lot of outside influences that can affect sort of how the Maine's forest economy works, right? And also temporally, because trees grow in a nonlinear fashion, right? You need to also account for that, right? So measuring something over 10 years in Maine's forests might come up with a much different answer than if you measured over 50, 80, or 100 years. With that, you want to also think about the environmental conditions, such as climate impacts that trajectory might have, right? And so if you're assuming that under a business as usual pathway, the international negotiations and countries still don't put in don't put in a lot of mitigation practices and policies themselves. And maybe you actually have the climate changes continuing to grow and extend itself, which can have an impact on how Maine's forest could grow as well, right? And so that's one way you can think about that. And we've sort of done that here, where we've actually looked at two different conditions. One is if sort of the world falls onto around a 2 degrees or less degree of carbon pathway, or if one where they sort of don't sort of ignore that and go on a more of a high emissions pathway that could lead to more climate change. The second thing you want to do is establish a list of acceptable or appropriate mitigation practices, like the list that I just gave on the previous slide. There's always going to be debate about what mitigation should be included. People have different opinions on sort of whether certain forestry practices are either sort of have the potential or capable of being implemented in Maine, given the sort of systems that we work in, policy mechanisms. There's also this question about measurement, monitoring, and verification. So, if you change your practices in the woods or at a landscape scale, are you actually able to measure what that carbon change might be? Can you monitor what people are doing in the woods, and can you actually verify that these changes have been made? With that, there's a lot of debate when it comes to these sort of natural climate solutions in general, issues about permanence, right? So we're working in natural systems. There's always the case that even unintentionally, there's going to be a natural disturbance that can come through, pest, fire, disease. The second aspect is additionality. So this question is, if people are already going and making silvicultural changes, so, they're already planning to put in a plantation because they're looking to get higher yields, something like that, paying them for the carbon, is that really truly additional or not, right? If someone's already planning to implement a practice, or maybe they're already doing it now, the question is, should we really sort of spend money trying to incentivize them to do something that they might be already? And the last case is leakage. And this is the question around that, okay, if Maine changes, it's sort of landowners in Maine change their behavior and maybe adjust how long they let their tree grow in terms of age before they fell it, right? Does that actually, that means that maybe in the next 20, 30 years, might not be supplying as much wood into the market, right, here in Maine, but globally, people still have a high demand for wood. So that might just mean that down in Brazil or in Borneo, they're increasing their harvest to meet that demand, right? And so that would be considered leakage. So just because they're not cutting a tree in Maine, and they're getting additional carbon sequestration benefit here, right? Market forces might actually determine that somewhere else, someone still needs a log that if it's not produced in Maine, it will be produced somewhere else. And therefore you have a sort of an overflow or a leakage effect that's not reducing global carbon emissions as much as you might have intended with your behavior. Okay, and sort of once you get around those practices and you have a business as usual, then you need to estimate the cost and effectiveness of implementing these practices relative to that case. So this is typically doing a suite of models and assumptions, and I'm going to touch upon that here. We're actually using more than one model to estimate some of the forest practices here in Maine. And it's a mix of economic and biophysical modeling. So you need to know how the trees will grow under different silvicultural conditions, but you also need to know sort of what might be the different costs of doing those different management options, both in terms of the actual sort of physical costs like planting trees, getting seedlings, doing some type of silviculture, but also the side of, if you change your behavior and wood flows are different than what the business as usual case is, then that might affect the opportunity cost or the revenue that one could get by changing those practices. We always attempt to be as empirically based as possible, but it can be complex due to the actual nature of the sector, literally, right? So natural processes, right? We have a lot of different experiments that we can measure the effect. We have different types of sort of remote sensing and modeling and things that can try to capture sort of what the effect of different management might be on carbon stocks, right? But in often cases, you have to sort of calibrate a model or something to sort of match that. You can't just, because of the complexity of how all this works. And the other thing that I'm just going to mention, but we don't really talk about in today's talk, is this: you also need to identify non-financial barriers of adoption. All right. Or so one case would be just, again, if somebody doesn't have the financial capital to go and start planting a bunch of trees, right? That takes more money than natural regeneration. And the other aspect is that we're not talking about, when I'm kind of giving these values that I'll give later on in the talk, I'm not explicitly accounting for sort of how the carbon market works, right? So there's cases, again, where there's a cost barrier because in order to sell your carbon on carbon markets, here in the US, there's different degrees of auditing and paperwork and transaction costs that you have to go through that can also limit, the ability for a landowner that has 20 acres to enroll in the project. All right, and that can be an example of a barrier of adoption. So again, some things to sum this up in terms of how do we estimate costs and benefits. So on the cost things, you're looking at opportunity costs. They can be in the form of yield reduction. So there might be some practices that actually change the overall yields relative to the status quo, and also the harvestable area. So if you're putting, you're changing the rotation age condition, or you're putting some forest in set aside and is not harvestable, that's going to change the amount of area that you can generate revenue from relative to what you might be doing in the business. The second would be capital or equipment, or in this case, seedlings and planting. There's also labor associated with that, and then maintenance on top of that for whatever practice you might do to prevent pest, disease, fire, weeds, that type of stuff. Benefit side, you could have yield improvements. So some of these practices actually might allow you to get greater yields, right? Because you're opening up the stand or you're planting high, faster growing species. You might have cost savings because again, you're not going in and harvesting as much. So that might change what you have to do. Maybe if you're switching from one practice to another, you're not going to have to have many roading and skidding charges. Benefit obviously is increased carbon sequestration as a result. And there could be other environmental co-benefits associated with improvements in water quality, habitat, biodiversity, et cetera. Okay, so I'm going to start off with an example just to get a rough idea of how I sort of do this. All right, and I'm going to start with the sort of most extreme example, and that's the idea of avoiding forest forests being converted to developed land. All right. The reason I say it's the most extreme because you're going to sort of get the largest opportunity cost differentiation, right? So somewhere in southern Maine, there's still pressure, in parts of Maine there are, but probably mostly it's sort of southern Maine where you're seeing the most pressure to, again, as there's more population and more demand for housing and other uses, you see that pressure of forests to be converted to something else, right? And the price of developed land is relatively high, or price of land that's going to be shifted into a subdevelopment or something like that, relatively high. So if you look at sort of historically and projecting that forward, there's been about 8,500 acres per year in Maine that have been converted from forest to some sort of developed land. All right, and so if you come up with a mechanism to essentially avoid that, right, it's roughly then that each year that forest that's not being converted is going to essentially grow an additional 3 tons of carbon dioxide per year. All right. So if you think about on average over 100 years or whatever, that's what sort of the average forest grows. If it's converted to developed, then there's not really any trees on it. And so if you multiply that 8,500 by the 3 tons, you get about 25,500 tons per, and that should be per year, not per acre per year, just for an example. But then on the other end, there's this economic cost, right? And so the idea is that if you're not developing that land, you got to look at what you could be getting for, say, you developed that and rented out that land, or you sold it to someone, you invested in something else, right? Relative to keeping as working forest land, roughly, even optimistically, it's roughly about $1,900 per acre per year. That could be the trade-off there, again, from sort of high quality developed land, forest land that could be then converted to development. So you do that, you divide that by the tons of greenhouse gas that could be reduced. All right, and as a result, you get about $633 per ton carbon dioxide equivalent. All right, so that's relatively high price. All right, but the reason we measured in that case is because basically everywhere, sort of when you're looking at comparing avoided conversion to afforestation to no-till farming to putting in a solar farm, pretty much we all sort of the way that the literature does it and policymakers do it is everything's measured in ton of carbon dioxide equivalent. So that's the sort of case there. So if you kind of went through and did this example, it would say, oh, that's really quite expensive. All right. And I'm kind of going to go, so I just wanted to start with that, but get around that the issue is because the land, the opportunity cost of the land is quite high if you're looking to shift into development. The other things that you can think about are things like perceived risk, right? And so of going into avoid, I said it's sort of permanent conversion, but that's not always the case, right? There's risk that there could be a fire or pest or something that comes through. The technical knowledge, again, it's probably not that hard to keep forest as forest, but there could be other aspects that go with sort of, putting into conservation easement or something like that can ensure that. And then just system compatibility. So is that approach to what we're proposing here align up with sort of, particularly if you're sort of a forest manager, landscape manager, or could be just a multi-land use developer, whatever, how compatible is this option with your sort of overall system? And I'm not covering these today. But basically we're doing a number of focus groups in the fall now that basically capture sort of what might of these other barriers to adoption might be for not just this practice, but a number of different practices. So like I alluded to, there's been some studies that have been done at the sort of US and global level that have done this for a number of different practices. And so I just kind of want to show here that basically this is a study led by Joe Fargione at the Nature Conservancy in 2018, went through and did for a number of practices throughout the US. In the forest one, what they did is basically They went through, they identified 6 practices that can kind of be implemented across the US. And then they went out and they looked at how much mitigation can come per year. All right, and then they broke it down to the sort of different cost categories. So this is sort of what you do is that exercise that I did before in the previous slide, and you do that for a number of different practices, a number of different areas, and it can help you to sort of generate what these curves might look like. And so they found that by far in the US, reforestation produces the most mitigation. Particularly, a lot of it can be done at $50 or less. There's sort of natural forest management, how to sort of enhance yields on naturally regenerating forests. They found that, again, you can get somewhere along the lines that even up to upwards of $50 per year, you get 230 essentially million metric tons. Avoided conversion's cheap, but there's not as much opportunity. And then ultra urban reforestation. All right, so the question then is this indicative of what you might be able to find in Maine? And that's why our argument of towards sort of going deeper and focusing on Maine specific models and numbers might come up with a different sort of assessment. Obviously, as I talked about, if Maine is 90% forest, we're probably not going to get a lot of mitigation coming from reforestation because there's just not a lot of land to go into. So to kind of build up with that, what exactly about Maine? So to date, most studies are global and national scale. There's some stuff in the Northeast, but not a lot, particularly not at this level that we really want to go down to. State level estimates are often reliant on assumptions that are more applicable elsewhere. Practices are also covered are more typical conventional forest management systems like in the South or Pacific Northwest. And here we really mean clear cuts. So a lot of forest economic based assessments, natural climate based assessments are going to just be like, are you clear cutting or not? Well, okay, if it's a clear cut, let's extend from 30 years to 40 years and look at the difference. All right. In Maine, that's not really the case, right? 90+% of harvested land is not clear cut, right? It's partial cut, right? So it's a much different type of forest system that's here. And the other aspect is just think about specific implementation barriers about whether that might be more specific to Maine than the broader US. So what I'm going to do now is I'm transitioning to how do we actually sort of bring these big pictures that I've sort of alluded to together and actually get numbers for Maine. So we're sort of entering the second half of the presentation webinar. So what I've really done is sort of looked at 3 different ways that you can do this type of modeling. And the first one, which is covering a bulk of what we've done, is basically through this use of what's called Landis modeling. So Landis essentially is a forest landscape model. All right, that is a cell-based system that represents a single species on a 30-meter resolution basis. All right, and what we're doing is the model itself has been parameterized by my colleagues Aaron Simons Lagarde and Casey Lagarde, amongst others, to sort of look at 10 million acres in the northern half of Maine. All right, and because that's already been parameterized and utilized in other projects, we wanted to build off of that and look at it more from this sort of carbon, various practice perspective its effect on carbon. We're looking at the time span between 2020 and 2100, so an 80-year time span. And we also can look at it under 2 climate conditions, right? And so that's the case where I talked about, what's the effect of climate change that might affect not just the baseline, but the mitigation potential. And so we can look at it under two different situations or scenarios to look at whether or not that's got a strong influence on what our estimates might be. And the key practices we use this model to look at are extending rotations, changing the distribution of partial and clear-cut harvests, doing actual explicit tree planting after we do a clear-cut in particular, permanently setting aside some land so that it's no longer eligible to be harvested. All right, so it's basically sort of making it a permanent conservation forest, not, that's basically just there to grow and that's it. And then also bundles that can kind of do mixes of above across the land. The second aspect of what we've done also is that, Landis is good at covering sort of forests as forests, right? And doing basically different management practices and harvesting conditions, right? But there's these other 2 that we sort of want to talk about as well. One was this idea of avoided conversion, all right? And so to do that, we need to project the amount of loss of forest to developed in agricultural land based on historical land change patterns or other scenarios. The one I'm talking about today is just on, we sort of took what's happened historically over the last 20 plus years and project that forward. What are we going to see? All right. And essentially then landowners can receive some sort of rental payment or essentially a payment to keep their forests as forests in perpetuity. All right, and so you then can look at the cost. And the thing I want to point out here is that, the way, historically, if you take what's happened and project forward, forests are expected to lose roughly about 100,000 acres per year in Maine. All right, and a bulk of that, something like 2/3 plus, is expected to go into development. All right, and so that's basically what I was looking at, is a big portion of the green line versus the yellow line in the example that I gave. There is expected maybe a little bit could go to agriculture, but again, that's not a huge case here in Maine. Whereas elsewhere, that's usually the biggest driver. On the other side, we can look at afforestation, and so this is planting trees in areas that are not forested since at least 1990 in land that's considered eligible for forestry. All right, and what you can see here is that a lot of times people think it's cropland and you put it back, but really we really wanted to focus on this in this assessment on more marginal land that's not used to grow food, land that might be growing hay but maybe is not at max production, right? And or potentially developed land that's more sort of either been abandoned, brownfield, sort of lower density development that could go back into forestry. So the idea here is that you're not basically taking prime agricultural land and planting trees in it, thereby taking sort of food production out of the scenario. And here landowners get paid for their current land use. So to sort of sum that up, essentially what you can think about it is a case of we have, and we want to measure that all to this business as usual scenario. So the business usual, we looked at the average rate of harvesting from 2000 to 2010, which is roughly 90% partial removal, 10% clear cut. When you're going in and doing these removals, about 50% of the biomass basically is removed from a combination of actually making the harvest trails, right, the roads and the skid trails, and group selection. All right, and we also established that the minimum mean stand age that's eligible for harvest is about 50 years. That means if the average tree on a stand is less than 50 years, then that pixel that I talked about on Landis is not eligible for harvesting at that point. But we also wanted to figure out, is it possible to maintain supply levels around what the 2010 harvest levels were, right? So the idea again is that you need to harvest enough wood to try to meet that target as well. Because the idea you really want to find out is, can we keep the forest products industry sort of sustaining at its current level, but also find ways to enhance carbon sequestration as well at the same time. So we're really looking for a win-win type of situation. The practices that we modeled, and I'll go through this quickly because I'll touch upon them sort of when I show some graphs in a few minutes. One is extend the rotation. So you increase the minimum stand age eligible for harvest. And so we looked at, original was 50 years, then we looked at 70, 85, or 100. Another one is to do this clear cut or partial harvest distribution. And so what that is doing is essentially taking the amount of area that can be clear cut to meet that basically 2010 harvest supply, all right, and maybe increasing it to 30% or 40 to 50%, all right, but still, again, holding that wood supply constant, right? So you can also think about it as a way to going back to maybe how Maine used to harvest sort of 30 plus years ago. The third case was planting. So this is after a clear cut, you actually add planting or artificial regeneration with about a 700 tree per acre mix of red and white spruce. So that's the sort of, you had in land that you have to choose what to plant. So that's what we sort of chose as our default species. Fourth is this idea of a set aside. So you can reserve 10 or 20% of the land that's permanently removed from harvest. So we just specify, okay, this run, make sure this much is locked in. Fifth is this idea of avoided forest conversion. So I showed that projection on the previous slide. You just want to hold forest area constant at the 2010 level, right? So that means no forest can leave and be converted to anything else. And six is afforestation, and that's the idea of planting trees in these areas that are considered eligible by sort of our conditions that haven't been forested since at least 1990. So how exactly do we measure this? Well, when I talk about forest carbon sequestration, there's two major components, all right? One is the actual forest carbon, and this is the annual change in the above ground growing stock. So if you go from this year to next year, how much more carbon is on the stand at that time, right? And that's how much sort of you can get credit for an additional sequestration. It's how much more did you increase your storage on a year by year basis. But also, when trees are felled, they're not all necessarily converted immediately to firewood that's burned or biomass chips or sawdust, right? some of that is converted into long-lasting products like 2x4s, houses, desks, furniture, et cetera, right? And so you can capture some of the harvested wood that's basically stored in products, or ultimately also tossed in landfills that are essentially trapped. We need to then measure that around the economic costs and benefits. So there's the harvest values. Those are estimated basically by looking at the harvest levels times the mean stumpage prices that are differentiated by product. Second is the opportunity cost. So what's the change in harvest revenue relative to the business as usual? But we note here it can be positive. So there can be a case where you actually get more harvest and more revenue in one particular year because of sort of just, again, on year how the sort of harvest schedules line up. Third case is one of those cases where we're doing clear cutting and planting. You need to know what the planting costs, which is deal with seedling site prep and spraying. And then also this land cost or rent, right? Particularly if you're basically taking land, converting it into forest, right? You need to buy that land or rent it out for your afforestation. Or if you're looking to basically not convert to development or not convert to agriculture, basically you essentially that landowner needs to rent out that land for what their highest and best use would be in order to offset what they could get from converting that land. So total cost itself becomes a sum of the opportunity cost, the planting cost, and the land cost. Collectively, that's the cost that we get. All right, so the next couple minutes, because I realize we're running short on time, but I'm going to go through sort of how do we get to I'm going to show just some results from some of the key scenarios in terms of how much carbon is coming off are we getting an additional carbon sequestration, and then what are the costs associated with it. So the first case here is that what we're doing here is that this is above and beyond on a year-by-year basis, how much more carbon can we expect to be getting from Maine's forests, all right, relative to the status quo, right, or business as usual case. And what I've done here is, and instead of showing you a bunch of lines that are really hard to see, I've tried to take those lines and distill them into a 20-year and a 50-year average, which just means sort of over the long run, on average, on any given year, how much sequestration are you expected to get over that business as usual case, all right? And the things I really want to point out here are a couple major ones. All right. First is if you extend rotations, all right, to that such that they're instead of 50 years, they're 100 years before you can cut. All right. You get a lot of sequestration on average over the next sort of 50 years. Not as much over 20 because you basically have to allow those trees to continue to grow. All right. If you transition to clear cuts, all right, but you still do natural regeneration, you get maybe 500,000 to 1 million extra tons per year. All right, so that's roughly 5 to 10% of what additional above what's actually happening on the ground now. But if you increase the amount of clear cuts, but then do planting to essentially speed up the rate of growth on that stand, all right, you can get 2 to near 3.5 million tons additional per year. All right, so that's quite a lot. That mostly comes from two major things. One is actually increasing the clear cutting amount. Right, but on top of that, you're essentially doing more artificial or plant-based regeneration. All right. The other things to sort of touch upon, there's this idea that you could follow the business as usual case, but maybe do more set aside. So that's set aside more permanent land for permanent forests or not harvest from there. That gets you again about 500,000. And then a forest, you might get about 600,000 to 700,000 per year for that sort of 400 to 500,000 acres that could be forested. And then if you're just focusing on avoided conversion crop, you could get a couple 100,000, but nothing much. I didn't include the development case in here because the numbers are basically, it's too costly that no one's going to consider to do that. Okay, so the second cost is, this is the amount of sequestration that you get, but how costly is it? All right. The practices that get you the most carbon are also the most costly. All right. The one where you extend rotations dramatically, it's more costly because you're essentially not cutting anything on a lot of Maine's woodlands for decades, right? To get from that 50 to 100, you need to basically change a lot of sort of how Maine's forests are harvested. All right. It's also more costly if you do this clear cut and planting case, because now you're not just doing natural regeneration, you're paying for the planting. Right, and so that comes out to, it's $509 per acre, right? But you're doing thousands upon thousands of acres per year. That's where it really adds up. And that's where sort of where afforestation comes out too, is that the price, the cost of doing some of the planting, coupled with some of the opportunity costs of where that's sticking out. So that, to dig into that a little bit deeper, we also want to think about sort of what our harvest flow is going to look like, right? Because this is the other side of the equation, is that you might get a lot of carbon. Maybe it's not too expensive, right? But at the same point, might not be that expensive for the landowner, but if you're on the other end of the supply chain and looking for wood supply, then you might question some of these practices one over the other. The case I want to point to here is that on the left-hand side, this is what harvests were in Maine. Again, projected under land is in just that 10 million acre case, right? So in Maine, actually harvests around 12 to 14 million green tons per year. In the area that we modeled, it's around 9 million green tons. So you can see that it's relatively constant around pretty much all the cases where we talk about ramping up clear cuts, maybe doing afforestation, right? All those make sense from that standpoint. All right. But if you extend rotations, that's where you're seeing the numbers go down, particularly if you extend to this 100-year rotation, right? On average, you just can't, there's not enough mature stands in Maine currently to allow you to meet that condition, right? So you might have to ramp up into that if you want to hold wood supply relatively constant, right? Here it's saying that you could potentially on average lose about 3 million tons per year in terms of harvest potential. So again, so you can take all this, so you got cost, you got sequestration, which is the benefits, all right? And you cost divided by benefits, and you get, here's the break-even carbon price, all right? This is dollars per ton CO2 equivalent. You can see they all have a positive price, which means you'd have to compensate landowners to implement any of these practices. None of these have basically, are free, all right? But you're getting on almost every case, you're getting somewhere along the line between $10 and $15 per ton, which is extremely cheap compared to a lot of different options that you might consider, particularly on the sort of more fossil fuel mitigation side of things. And interestingly enough, even though there's a large opportunity cost associated with the lower wood production and lower revenue from timber, right? Because you're getting so much more carbon under that 100-year rotation case, it still looks relatively cheap from that perspective. The other thing is, again, you're getting a lot of carbon off of those cases where you have more clear cuts, but increase planting, all right, such that it's, again, falls within the $10 to $15 case. It's because you're getting that much more carbon for the cost of planting, so they sort of balance each other out. So again, pretty much across the board, we're looking at things at $30 or less, which is it's pretty much in this scheme of doing comparisons are extremely cheap options. So we can take all that and then just say, okay, essentially summarize and synthesize that into a number of different practices here, just taking the previous sort of three, 4 slides and putting this all into one to look at how they compare again. And what it's really showing is that, focusing on planting of trees could get you a pretty big bang for the buck. The rotation situation in terms of extending rotation could be another option, but of course, these are very dramatically different things to think about from a sort of biological, biophysical perspective, wood supply perspective or whatever. It's sort of two extremes, right? And so that's kind of ways you got to think about that. But there's a lot of other ones sort of in the middle of the road that can also sort of achieve additional mitigation, right? But nothing near as intense as sort of these other cases. And so you estimate basically if you take either practices that have to be implemented on their own, or maybe some of these can be summed together, such as the case of like doing the planting plus afforestation plus avoided conversion, you can get somewhere between 0.2 to 4.3 million tons per carbon dioxide per year. All right, with that higher end, sort of getting you much closer to essentially carbon neutrality. And the total cost would be somewhere between 4 million and 72 million per year. So it's, again, this is costly stuff to some perspective, but if you break it down to dollars per ton, it's going to be a lot less costly than probably other types of implementation practices you could be thinking about on the sort of non-forest side of things. So to just put this together again, think again, like I said, Maine right now, if you do blue, sum the blue and the green line, you get somewhere around 5, 6, 7 million tons of carbon dioxide per year sort of remaining. Here we estimate that in some of these cases, you could get close to 4 million, which gets you even the way we are today, close to that sort of carbon neutral case. You combine a few of these practices, you could get roughly 5, which is similar to that gap that we needed to meet. Could help to sort of help meet that gap. If sort of things continue as possible. And just to quickly sum up, there's a number of different practices that I looked at. The mitigation total, the extending the harvest age was sort of the trade-offs there is not necessarily directly on the cost, but what the downstream effects could be on the supply chain with timber supply being reduced. Increasing clear cuts and focusing on planting were found to also be extremely beneficial in terms of carbon and relatively cheap. You could do this middle of the road case where you only increased your harvest age from 50 to 85. All right, you don't get as much of a bump down in supply, but it's still relatively cheap. Or you could do a clear cut area with natural regeneration, all right, which is sort of falling further back to maybe sort of how harvesting was done in the 80s. And again, not get as much carbon, but still sort of be in that range. The key also is that most of these practices allow harvest to continue to follow business as usual, except for that number 1 case, the 100 years. And also just to compare to what I talked about on the agriculture side of things on May 12th, costs are typically cheaper than agricultural practices on forestry. So here we have a lot of things that are in $10 to $30 range. On the ag side, we had $25 to $100+, right? And Maine has a lot more forest land too, which can also mean that you can get more sort of bang for the buck. And ultimately, they're also a lot cheaper compared to typical carbon prices for other sectors of the economy that look at often they're $40 per ton or more as well. So thank you for that time. I'm here to take questions for as long as you guys need. As I realize some might be like a sort of hard stop at 1, but again, I'm welcome to take on more, or you can email me. I just want to thank all our collaborators and funders, particularly on the forestry side of things. Dr. Aaron Simons-Lagarde, Ivan Fernandez, and Aaron Weiskettel all helped with the modeling and sort of bringing together some of these assumptions. And we have a number of funders that have gone towards this. The largest one being specific to this work is the United States Climate Alliance as well. So thank you for that. And John, I'll hand it back to you to moderate the discussion.
Okay, thank you, Adam. Sorry we went a little bit long, but if you gotta go at 1, go ahead and go, of course. But if you have a question, you can put it in the chat box if you know how to use that, or you can just email Adam, and I'm sure he'll answer you. So use the chat box or email Adam. If you can stay on, I think Adam will stay as long as you want to stay. So I would say we're going to open the floor to questions. You can, if you see the raise hand function at the bottom right of your participant panel, use that. Or we can, Adam, are you seeing the chat panel? You can start answering.
Yeah, so I can pick up the first one.
Okay.
So Jesse asked, and it's a good question. So, so with longer rotations, right, and basically greater carbon sequestration, or at least carbon storage over time, does the harvest per acre effectively increase, right? After all, trees are made of carbon. So the idea, again, is that you're transitioning from this sort of standard 50 years on average, right? The amount of, basically the amount that you're harvesting off the stand, right? If you're on roughly harvesting only 50%, right? And then as you go, you got to get up to that 100-year stage, right? You're actually going to also be doing more removals from any given stand. So that's a good point. The key is exactly how you got to go about to transition from one to the other. So the question was, and I think I'm going to look back and to verify that I think you're still, I think over time, getting close to harvesting the same amount. So which basically also says that maybe you're changing the amount that you might be harvesting, but I got to go back to the modeling for that. The second question is, can you make this presentation available for other groups? So John, that's you, but I believe, within the next 24 to 48 hours, it's going to be posted. And I'm happy to share my slides, which can be posted along with the actual.
That's right. It'll be at the Maine Climate Table website, both the recording of the webinar and Adam's slide deck.
Yeah. So Rich is pointing out, did you model an increase in the value of carbon credits over time? I've read that projections that carbon credit values increase plus or minus 5% above inflation. How does the impact your projections and the cost profile? All right, so that's great. So you're spot on with that. In a lot of other modeling I've done, So I want to step back. So what I've done here is I've tried to say, we're going to do a practice, and we know that, and we're going to estimate how much sequestration you get from that practice, and then from there I can back out sort of the relative dollar per cost that it takes to implement that practice. And we get essentially those numbers that I gave you where I said $10 to $30 per ton, or essentially the break-even price. So that's the amount that a landowner would be willing to receive to implement that practice instead of the business as usual, right? So that means a carbon price, and I said, oh, that's relatively cheap, because exactly at what the question was getting at, right? Is that on average, people are expecting that, right now, the social cost of carbon, basic carbon prices should be about $40 or more if people actually, care about this. And as more and more sort of ramps up, you're going to get higher and higher prices, which what that's going to basically mean is that there's, even if you take account transaction costs and other things, that because these numbers are extremely cheap, there should be more and more people willing to overcome some of those other hurdles associated with just the break-even cost to want to implement these practices, right? So on the other side, some models have done is they give a price and then they look at how much sequestration would come at that price. I've done the opposite. I basically just said, let's do how much sequestration for a practice and then estimate what the price might be. Okay, next one from Denny. Any thoughts on who pays the $15 per ton, the taxpayer, the carbon emitters? Right, so I'm sure, yeah, so we can have part 3 where we talk about policy of carbon markets and who's supposed to go. Right now, I'm going to be agnostic on that one. There's a lot of different ways that we could go down that route. I mean, it's sort of more, there's the cap and trade programs that tend to be the emitter are the ones that pay, right? The Maine Climate Council is thinking of a bunch of different options that could basically essentially act as a way to transfer money to the landowner, of which maybe it could be through a taxation scheme. There's been a question of whether or not you could adjust something like current use taxation laws to account for carbon as a sort of forest product, things like that as well, that could lead to that.
Adam, just while we're on that, before you move on, not that we want to go down the policy road, but if the state has set a carbon neutral goal, which it has, wouldn't it be responsible for paying for that goal?
Yeah, exactly. So, but the question is the state is also basically, the counter to that is the state has set an 80% reduction in fossil fuel emissions goal, right? So the state should be responsible, but how are they thinking about that, right? It'd be like increasing tax on gasoline, putting emissions caps on certain industries, right? Which ultimately then is the question of if you put a tax on gasoline, right, then that's essentially potentially passing on the cost to the consumer in the first stage, right? So then who's paying? Well, the person who drives the car, right? But there could be other mechanisms that use sort of that taxation scheme and the revenue to offset some other costs that
maybe the gas tax could be used to pay the forest owner or something.
Yeah. So again, this is where we could have an entire have whole seminars on this.
Okay, giving us a great idea. Okay.
Yeah. Okay, Allison, would you expect the results of the model to vary much for separate ecosystems in Maine? Yes, I would. I expect it to be some degree. I think also across landowners to some aspect. And that's this great. I didn't have a slide that says sort of next phase of the modeling, but the next phase is actually going to look at that. We're going to break this out sort of more by ecosystems and particularly by major forest types. So that allows us to sort of look at sort of different aspects from that case. The other one is not for this project, but in the future, we're looking to expand that 10 million acre sort of geographical sort of boundary that we've set for the landscape modeling. To be more of all of Maine, to capture more of those dynamics that might be different in southern Maine, both from a biological, but also from a maybe sort of landowner, different sort of distribution of landowner perspective.
So if it would vary, are you saying it would vary enough that the relative benefit of your different management scenarios would change?
That's what I'm thinking, but I don't know. We haven't looked into the numbers yet. So yeah. Aaron Simons is producing those maps as we speak, and so that's sort of what's hopefully going to come out in the next month is that aspect. My
Great.
guess is there would be some variation, particularly in like areas of spruce fir versus, maple beech birch or something like that. But I
Yeah.
can't 100% say, yes, there's going to be, one is going to be twice as expensive as the other.
Okay, thanks.
Okay, Jesse again, does your analysis take into account consideration of current use taxation schemes related to forest, ag, and open lands? No. So right now we don't take that into account explicitly. What the question or the way I have it is that, if they're already enrolled in a current use taxation, right, and they switch their silviculture, it's still going to basically be, they're still going to adhere to that. The bigger question would be is if they go into permanent set aside, right, and they're enrolling tree growth, well, then there's going to be a penalty for that, right? And so that's one thing we might have to think about in consideration about that aspect. Right now, we've sort of assumed that again, in any of these practices, the sort of current management or the current sort of policy that the landowner follows is consistent. Richard Nelson says, to what extent is planting practiced in Maine right now? So there are some plantations. I know that J.D. Irving is sort of the largest as far as I'm aware in terms of planting. Primarily that's up in northern Maine. There's been people have tried planting of various species over time, but it's never, I don't think it's really caught on as far as I know as being sort of a really considered really important silviculture practice in Maine. But part of that is sort of relative to the economics of how it works, right? And so if you can throw on carbon on top of timber value, then that might, basically what we're trying to get at here is that might make it be sort of biophysically, it's possible. It's not, there's no limitation there as far as I'm aware, right? And so it's just more from the economics, not necessarily lining up. That's been limited to why planting has not been as ubiquitous in Maine and the Northeast as it been in other parts of the states. What land cover types were put into the category for potential afforestation? So I'll go back to that slide. The numbers were basically, if you look down in this bottom right, it's basically got roughly around sort of 500,000, 400 to 500,000 acres. A bulk of that, over 50%, was as pasture. All right, we had a little bit of very marginal cropland that also sort of qualified as that, and a bit of what I would call low density developed land. So this could be sort of brownfields or sort of abandoned other areas, maybe sort of large, I don't want to say city parks or something like that, that was classified as development, but looked like there wasn't a lot of other use there. Let's see. And the second question, which this is very good. So the question is in terms of this reforestation area, is that just based on the northern part of the state? No. All right. So the only stuff where I looked at just the forested, just the 10 million acre part is the ones where I changed the different practices, which is only looking at this case here where we have the large sort of boundary. All right. For afforestation and avoiding conversion, a lot of that was actually on the southern half of the state. But so I had basically models that allowed me to look at both of those cases for the whole state, right? And so that's the case there. So good question. The other thing that I can get at is that roughly, so I kind of give these numbers, right? But only the top 3 here are the ones that cover the whole state, even though I say total Maine mitigation. If roughly you wanted to take that 10 million and get acres and get closer to what it might be for the whole state, you can maybe roughly multiply by 1.4 to 1.5. All right, because the ecosystems are slightly different in the different parts of the state. The actual sort of business as usual silvicultural practices are somewhat different. The grade of harvest, like removals to growth, are somewhat different. But that's sort of one way that we could scale this up. Like I said, in the future, we're looking to get from the 10 million up to the 17.5. So that's all I see on the chat, John. I don't know if others have more. Again, you're always free to email me. It's pretty easy to find me if you can spell my last name. I'm always more than happy to take any and all comments, share information, point you to directions of other sort of literature, etc. Yeah, I guess we got one
We
more.
got one more? Yeah, and
One
again,
more, yeah.
anybody can
And you
jump in. You don't have to type. You can speak too if you'd like.
So did your estimate of the mean carbon sequestration for set-asides equal 3 tons per acre per year? And does that just pertain to the northern forest region? So yes, so it was equal to, I think it was equal to 3.1 tons per acre per year. And it's not for the northern forest region. So what I took there is I took basically from the US Forest Service's FIA data. I essentially took sort of what they estimate under basically the sort of the average growth of a forest in Maine, sort of the trajectory as it went up over time, looked at that, converted that to carbon, and then basically used that to look at what the average might be over different points in time. So at the 50-year period, it's roughly that 3.1.
Yeah, the leakage. You see the leakage question?
Okay.
Yeah.
So from Denny, if wood supply does not go down that much, is leakage then not big of a concern? Yeah, so I'd say no, right? So if we can manage to maintain harvest levels, then there's really no concern about where, again, relative to the business as usual, right? Which we assume that harvest levels are just going to be relatively constant over time, then you don't really have to be concerned about leakage. Again, you have to come up with policies and mechanisms to ensure that happens, right? But that was one thing we really wanted to look at is it possible for Maine's forests to keep their wood supply relatively constant, but actually enhance carbon sequestration? And then we found that almost in every case, that is indeed possible. So with that, right, if you're still producing, in this case, we said in Maine's northern forests, 8 to 9 million green tons per year, then you don't really have to worry about the leakage aspect because essentially you locking up some wood in this part of Maine is just leaking over to another part of Maine, right? And that's fine if the boundary we're looking to estimate this over is just Maine. You're still basically over your footprint, you're basically getting the same amount of wood. Great question.
Adam, is anybody up at UMaine working on sequestration in durable forest products and how that might factor in, if we switch to more?
Yeah, that's a great question. So we're so there's people within the School of Forest Resources that are more on the wood product side that are looking at just making different products out of wood, and I'm sort of loosely associated with those products as being the guy who comes in and does very similar to what we presented today, but looked at if you start making particle board, with nanocellulose-based fibers as the binder, will Maine have enough wood supply? Where will it come from? And what sequestration potential would be? Again, with cross-laminated timber, question again is, if we transition more and more wood towards these longer-lasting products, what might that mean? Again, what silviculture practices might we have to implement to get more, more or less, grades of different type of timber and that type of stuff as well. So I have another thing where I'm looking at sort of, if you ramp up production in Maine, can wood supply still be met and can carbon conditions still be met? And to date, what I found is basically it can, because what it does is incentivizing landowners because you're getting more for your wood, all right, to actually do more investment in your stands, therefore actually getting more wood per unit of acre or whatever as a result.
Adam, this is Denny. Can you hear me?
Yeah.
Hi, thanks a lot. I'm sorry I misspelled wood.
Yeah, I got at least it's phonetically right?
For me, the fact that leakage could be not a concern for this kind of is a gigantic conclusion, because that's a big criticism against carbon offset programs. And in the California market, you get an automatic 20% deduction as a landowner, which could be eliminated if we had a sort of an in Maine structure. So I think that's just a fabulous conclusion here.
Yeah, thanks for that, Denny. And the key part is exactly that, right? Is that because this model and this sort of the geography that we set it at is landscape scale, right? And so that's the key where some of these other issues come into line, right? And so it's like, yes, one parcel of land might enroll in a certain practice and therefore not harvest as much, right? But if you sort of can have landowners work together through some sort of scheme where someone else makes up for that shortfall, right, and ensure that there's enough wood to do it, then that's sort of how you can eliminate that, again, that leakage outside of Maine type of situation. Okay, Roger's got a question that I'm going to punt on, but I'll try anyway. How would you address the loss of biodiversity that likely comes with the planting trees and plantations? So that is a good question. So that's why we talked about this mix of, and I didn't touch upon too many of the scenarios. There were more that we've done and that we're finishing up. You could have more of this thing where you take this sort of the triad approach, where you have a certain amount that's intensive plantations, certain amount that's natural regeneration, and a certain amount that's permanent set-asides, right? We've done some scenarios sort of that I didn't touch upon here because we're sort of rerunning the numbers, but it's sort of looking at that can also maybe not get you as much sequestration as some of the just plant all that stuff that we talked about, but you can sort of use that approach and probably still maintain a lot of the sort of habitat you're looking for, and or by putting more area into this sort of set asides, you're getting transitioning at least that more of that area into late successional forests that you might not actually be seeing in Maine today. So that's another great question, Roger, that we are thinking about and touching about. So the next iteration is going to talk about that aspect of a little bit more.
Okay, Adam, I think we wore everybody out. So
Okay.
get in touch with Adam. If you've got questions, go to the Maine Climate Table website. Give me a day or two to get that posted. You can watch it again. The slide deck is great. I know I want to spend some time with it too, so that will be posted. And thank you all for joining in today, and especially thank Adam for sharing his thought. Part 3, policy. Now I know what the next one is going to be about.
Yeah. Thank you, John, and thanks to everyone for taking time out of Monday to listen in. Great questions that got me thinking. So that's excellent.
Yeah. All right. Have a good day, everybody. Signing off.